All right, so let's take a look and see how you guys did with the 3 practice problems that you did with day 5 using that molar volume conversion. So this first problem started out by asking you how many moles are contained in 2.5 liters of methane. So my given is volume. It wants to know moles. You should have taken the 2.50 liters of the CH4. If you follow your roadmap, this is a one-step problem. We have a direct conversion to take us from liters to moles. Based on the setup, you should have put 22.4 liters in the numerator, 1 mole in the denominator. Oh, I got that flipped around. 22.4 liters in the denominator, 1 mole in the numerator. So you should have divided to solve. When you divided that out, you should have got approximately 0.11 moles of methane CH4. Moving on to the next practice problem, it asks what volume will 95 grams of oxygen gas occupy? So in this particular example, you're starting out with a mass, and that's 95 grams. So if you follow your roadmap, it needs to get from grams to volume. Volume is measured in liters. So the only way that you could get there was starting out with molar mass of oxygen. Now with oxygen being a diatomic, you have to be careful. You need to take its mass times 2 because there are 2 oxygens to account for. So oxygen gas isn't 16, but 32. Because you started with grams, grams should have went in the bottom, and the mole should have went in the top. The last piece is to get it to volume. So you know you're not done because your units cancel out, you're left with mole. To get to volume, we're going to go ahead and put 1 mole in the bottom and 22.4 liters in the top. Whichever way you prefer to solve, either way should have worked out to give you approximately 66.5 liters of oxygen gas. You had one last example to work through. Let's see if I can get my screen to clear. All right, there we go. So we have practice 3. It asks how many liters will 0.75 moles of nitrogen gas occupy? And so with that particular style example, we're starting out with moles. And for some reason, it's cutting off on my iPad, but it doesn't look like it is on the screen. Kind of goofy. Okay, so we have 0.75 moles nitrogen. It wants to know how many liters. So when you go to set this up, you're starting at moles, going to liters, which again is a volume measurement. This is a one-step problem. The only thing you needed was to put 1 mole in the denominator and the 22.4 liters in the numerator. So this one you mathematically needed to multiply to calculate it out, and I got an answer of 16.8 liters of nitrogen. So the only practice problem that required 2 steps was number 2, because you started out with something that was not the mole and ended with something that was not the mole. So you can look at the map, only one-step conversions will be where you start with a mole or end with mole. So for example, 1 and 3, you started out with liters and moles, and vice versa, you ended with moles and ended with liters. So those only required 1 step versus you went from one outer unit to another outer unit on that map. Reach out to me if you have any questions or concerns.